In this video, I want to show you an example of the execution of Dijkstra's algorithm. Dijkstra's algorithm is the algorithm that's meant to figure the shortest path between a given node, so in this instance, a given city in the graph, and every other city. So the algorithm is outlined in the handout and also in the description of this video. So try to follow along. So, let's say that what we're trying to do right now is figure out the shortest distance between TO and everywhere else. So the first step is to add TO to the unvisited list, and the associated distance with TO is going to be 0, because the distance between TO and itself is going to be 0. We're going to be keeping track of the associated distances to the unvisited cities. Those distances are tentative and might change as we execute the algorithm. So this is the start state, and this is saying that we're going to be figuring out the distances to cities from TO. Okay, so the execution goes as follows. We take the unvisited city that's the closest to TO according to those tentative distances, and we put it in the visited list. Then we populate the unvisited list more. So let's do it. The closest one and the only city in the unvisited list right now is TO. The distance to it is 0. We move TO to the visited list, like so, and we copy the distance from here to here. This is a 0. Well, this was kind of easy. When you add a new city to the visited list, you take all the neighbors of that city which were not already visited and add them to the unvisited list. So TO has 3 neighbors, SF, CDMX, and NYC. Right now the only visited city is TO, so we should add all of those to the unvisited list. What are the distances to SF? Well, the last thing that we added was just TO. So the only possible distances would be via TO, which just means that the distances would be 6 and 7 and 3. So let's add those. So it would be SF, 6, and CDMX, 7, and NYC, 3. Okay, we are done with the first iteration. The next iteration would be picking the city from the unvisited list, which has the shortest distance associated with it, and moving it to the visited list. Let's do that. So when we move NYC with the tentative distance 3 to the visited list, we copy this distance to here. This is already settled. Let's move NYC 3 to the visited list. And let's remember that this is 3 right now. So now what we do is we auto-take the neighbors of NYC, which were not already visited, and add them to the unvisited list. So NYC has just 2 neighbors. TO is already on the visited list. DC is not. The distance between NYC and DC is 2. So we auto-add DC here and say that the associated distance with it is 5. At this point, we can just forget about the 3 here. That's already settled. And we will not be using that anymore because we already added all the possible neighbors of NYC to the unvisited list. Next iteration. The closest city is DC with a distance of 5. So we take this 5, we copy it over here. And now we move DC5 to the visited list. So DC5. Next we populate the unvisited list with all the neighbors of DC which were not already visited. So DC has two neighbors, NYC, which was visited, and SF, which was not visited. So SF was not visited, but we should check that the distance should not be shorter here. So the distance between DC and SF is 5, so TO to SF would take 10, so we should keep the 6 over here. So nothing changes. Next, we take the next closest one, that is SF, and we want to move it to the visited list. So we erase SF from here, we move SF over here, this is SF6, and we write down 6 over here. What about the neighbors of SF? Well, SF is neighbors with TO, that's already been visited. SF is neighbors with CDMX, that's over here. We should check that 6 plus 3, the distance to SF, this 6 plus this 3 is not smaller than 7. It's not, so this should stay 7. And DC was already visited, so we needn't worry about that. All right, next up is we're done with this iteration. Next iteration, the only thing left on the unvisited list is CDMX. So CDMX ought to be moved over here. So CDMX 7. This is the distance, TO to CDMX. Gotta be 7 because we just copy it from here to here. Does CDMX have any neighbors that are not on the visited list already? Well, no, because its only neighbors are SF, which is already on this list, and TO, which is also already on this list. We're done, and those would be the shortest distances possible between TO and everywhere else.